Okay, in this video we're going to go through the 4.2 notes in our calculus book. So the focus in 4.2 is on the exponential function ex. So e is your base, okay? That's an irrational number. The function f of x equals e to the x. Okay, it's also called an exponential function because the variable x is the exponent. Okay, so you've got your base and you have your exponent. Okay, so we did this general topic in 4.1. So I'm just illustrating things here for you. All right, so e is a number just like pi in that it's irrational, and its decimal never repeats and it never ends. So an approximation that sometimes you see used for e is 2.71. Just like the approximation you see sometimes used for pi is 3.14. For our purposes, we're going to keep our answer, for the most part, in e. So we'll get to that a little later. So in section 4.2, the authors discuss finding the slope of exponential functions using limits, and they go through several examples. So it is a good idea to read this section and just get a sense of what they're talking about. Their work leads them to discover that having the base be e simplifies matters greatly. To see why base e is so special and easy to work with, let's look at the derivatives listed below and see the pattern. So doing that, I have the derivatives. So I've taken the derivative. So the derivative of this function, e to the x, is e to the x. Okay? So that's interesting. Now look at this next one. The derivative of this function, which is e to the 2x, is now 2 times e to the 2x. The derivative of e to the x to the 1/2 is 1/2 x to the negative 1/2 times e to the x to the 1/2. And lastly, the derivative with respect to x of e to the negative x is negative e to the x. So can you figure out the rule? So I'm going to give you a second, or you should give yourself a second to think about that, and then I'm going to tell you what it is. Okay, so if you're done thinking, let's explore this together. What if I write my function as e to the f of x? Does that give us a clearer way to express the pattern that we're seeing over here? So I would say yes. So that derivative is going to be take the derivative of the exponent and then multiply it by exactly what you see. So e is ez, okay? This is what I see right over here. Here is the derivative of what? Of the exponent. So let's try one. What if I say take the derivative with respect to x of e to the 7x? Wouldn't you say, okay, the derivative of the exponent is just 7 times exactly what I see? That would be your answer. Okay, so think about that as we get ready to do a couple of problems down here. So it says, now apply this new information to prior calculus problems. Find the equation of the tangent line. Oh, that's our favorite thing to do. Remember, y equals y1, y minus y1 equals the slope times x minus x1. Okay, so I'm going to find the equation of the tangent line to the graphs of y equals e to the x at x equals 3. So right away, what do I know? I know this has to be 3. Then they tell me use e to the 3 equals 20. That makes this 20. Now, if my function was e to the x, what is that derivative? That should just be e to the x. And then can you evaluate that where e is 3? Well, excuse me, where x is 3? So you should be able to do that. So if x equals 3, then that's going to give me a derivative of e to the 3, which they want me to use a 20 to represent that. So that would be your answer. Okay, let's go on to the next page. Okay, here it says solve the equation 4e to the 6x equals 80. So this is similar to what we did in 4.1 as well. So you should try to isolate your e to the 6x by dividing both sides by 4. Okay, that's going to give me e to the 6x equals 20. Oh, look what I have here. They want me to use e to the 3 equals 20, so go ahead and plug it in right here. Now you have unique base. In order for these exponents to be, in order for these expressions to be the same, so e to the 6x equals e to the third, that will only happen if the exponents are the same. So set them equal. Divide by 6, divide by 6, you should be getting e to the 1/2. Or excuse me, x equals 1/2. Okay? So same idea, use this unique base, get the bases to be the same, and then set the exponents equal. Okay, our last thing, look at this. Many of you will get this wrong right off the top. And you get it wrong because you wouldn't recognize that you had to do product rule. So if you know, I'm going to write it down here, that y equals, this is the left side, whoops, and then this is the right side. Okay, so left, right. Therefore, y prime equals left, just write what you see, times the derivative of the right. Well, that's going to be e to the x times the derivative of x, which is just 1, so I can write e to the x, plus, so I did lefty right plus right d left. Look at the left carefully. Do you see that you really just have 3x squared plus 3 when you distribute, and that derivative is going to be 6x. So can we make this look prettier? Factor out what you can. What can we factor out? Definitely need the x, but how about the 3? So I can factor that out, and then I'm going to do my box to show that I've done greatest common factor factoring and keep everything straight. So that's going to be x squared plus 1. Bring down that operation, and then I'm going to have what left in there? It looks like just x. So y prime equals 3e to the x times x squared plus x plus 1. Okay, and that would be your final answer. Now, a word about this. You want to think about, what does e to the x look like? And doesn't it, let's see, if it goes through, if my x is equal to 0, then anything raised to the 0 power is 1. So e to the x looks like this, right? Y equals e to the x. It is asymptotic to the x-axis. It's never going to have a root. So therefore, let's say, just for argument's sake, that I wanted you to tell me where this function has a critical value. What you should know is that you will never, ever, ever get a critical value from this component, the e component. And why is that the case? Because this will never, ever go to 0 and cross the x-axis. Okay, so if you're asked to find a critical value for this kind of setup, all your eggs are going to be in this basket. Set that, factor equal to 0, and solve. Okay, so that will give you a little insight into some of the homework.